So in this lecture we are going to see how to convert infix expression into prefix expression. In the previous video I have discussed the infix to postfix conversion using stack. Now we will see the infix to prefix conversion using stack, right? See, here also without stack you can convert from infix to prefix like we have discussed in the previous case. See, let us take this example. I have same example I am taking that I have taken in the previous video, right? So here also you should know the precedence and associativity of the operators. This is the prerequisite of this video, right? Now we are going to follow those precedence and associativity rules. First of all, see, check out the precedence of these operators. Which one is higher precedence? This multiplication is having higher precedence, right? So first of all you need to solve this expression, that is B into C. See, these are what? Operands, this is what? Operator, right? Now prefix expression means if this is B into C means these are operands, this is what? Operator. In prefix this operator should be before these operands. In postfix this operator should be after these operands. Pre means pehle, post means baad mein. You can relate it with prepaid mobile and postpaid mobile, right? And infix means this operator is in between these operands, that is infix expression. So this is what? Infix expression. Now precedence of this is higher, so first of all you have to solve this one. So prefix of this is what? Asterisk B into C, right? Now this says what? One operand. Now we have plus this operator and this is what? Another operand. This operand, we have two operand and in between these operand we have now plus. This is what? Operator. Now we are going to solve for this one because I have left with only one operator now. Now for prefix this operator should be before these operands A, and second operand is this one, means asterisk B, C, right? So this is what you can say a prefix for this infix, right? In this case also, in first scan this will be solved, in second scan again we will solve for this plus, right? So there are multiple scans to solve this problem without using stack. Now here in this case I am solving this. This is a smaller expression. If this is the expression, then here multiple scans would be there, maybe 10 or maybe 20, 15, I cannot say, right? Now rather than scanning it multiple times, because this process is very time consuming process, very lengthy process. So we should follow a method in which we scan only once from here to here, and after reaching at the end of this expression we will get our output. You can say we will get our prefix expression. We don't need to scan this expression multiple times, right? So that would be what? Efficient algorithm. So that is possible using stack. That is why here I'll discuss with you conversion of infix to prefix using stack. We will also discuss, to tell you our answer, we will also discuss how you can convert this expression without using stack at last. First of all I'll convert this, after that I'll write down all the rules here only. So now this conversion is also same, almost same as the infix to postfix conversion, but the difference is what? First of all you need to reverse this infix conversion if you are converting this into prefix, in that case only, right? So first of all reverse this one, means we will start writing from here. So here we have Q, so here you will write Q, then after that plus T, multiplication V, then divide, then U, then divide, then W, then again multiplication. Now this is what? Closing parenthesis. So here also I am writing closing parenthesis, right? Now this is what the reverse of this infix expression. Now somewhere it is written that here in the infix, in the reverse of this infix, reverse these parentheses also. If this is closing parenthesis in the infix, here write down it as opening and here write down it as closing, like this. But here I am not going to follow that process, right? That is also fine. You can do something like this, after that convert this into postfix and after that reverse that postfix expression. But I am not going to do this, I am going to follow the second approach, right? This is now a reverse infix expression. Now see, same we are going to take one stack. If operator will be found then we are using stack for pushing those operators, and if operand is there, then directly we are going to print those operands, right? Now scan this reverse infix expression from left to right. You can scan it from right to left also, and after that also you can get the prefix expression. So there are many ways, 2 or 3 ways to convert infix to prefix, right? This is one of all the possible ways, right? Now here we have Q. So we are not going to push anything into the stack. If operand is there, directly print it. Fine. Next, plus. This is what? Operator. Now see, is there anything in the stack? No, directly push it. Now we have Q in this prefix expression only. Now we have T. Nothing to push in the stack, directly write down here, print it, right? Now we have asterisk operator or multiplication operator, you can say. Now check. If in stack I have plus, top of the stack is this one. Now we are going to check the precedence. See, now if the incoming operator is having higher precedence than the top of the stack, then what you will do? Simply push this operator here, means plus into, and here we have Q, T. Now next is V. So no need to write down anything in the stack, directly write down this one here. Next is divide. Now see, check out the top of the stack is multiplication, right? And precedence of this and this, divide and multiplication, are having same precedence. In that case, check out the associativity. Now, associativity of this is what? Left to right. So if associativity is left to right, then simply push the incoming operator into the stack, right? But that is not a case in infix to postfix conversion. In that case, if associativity is left to right, then pop out this one, right? And again check the incoming operator with the new top of the stack. But here the rule is different because we are converting infix to prefix now, right? So now here we have Q, T and V. Now we have U, means simply write down here V, U. Now again we have divide. Check out the top of the stack is having divide. Same precedence operator is there. Incoming operator is the same precedence of this operator. Now check out the associativity rule. Left to right. In that case, simply push it, right? And here I have Q, T, U, V and U. Now next is, after this one I have W. Now stack would be as it is, and here we will append this W, right? Now asterisk. Now check out, again same precedence, associativity is also left to right. No need to pop out, no need to do anything, simply push it into the stack, right? Now after this, see, now I have closing parenthesis. Now in this case, if you find any closing parenthesis, simply put that parenthesis into the stack, right? In previous case, infix to postfix, what we have done, if opening parenthesis is there, then push it into the stack. If closing parenthesis is there, then pop out the stack one by one, right, till you find the opening parenthesis corresponding to that closing parenthesis. But here the rule is different, reverse. Now simply push it into the stack, right? Now here we have, now after this we have P. No need to do anything, simply append this P here. Next is exponential. Now see, here we have closing parenthesis, right? So if any operator comes after this closing parenthesis, simply push that into the stack. No need to check out any precedence, right? Now simply push it. After this we have O. Now directly you will write O here, and the stack would be unaffected, right? After O, now I have what? Opening parenthesis. Now in this case, if you find any opening parenthesis, if the next symbol is opening parenthesis, then what you will do? Then from the stack pop out all the operators one by one, right, till you find the closing parenthesis corresponding to this opening parenthesis, right? Here the rule is reverse. Now see, we have top of the stack is having exponent, so first of all pop out this one, right? Next is what? Now we find closing parenthesis. Now stop, no need to pop out anything, right? And no need to write down these parentheses into the stack. Now the remaining stack is plus, asterisk, divide, divide and asterisk. Now after this we have plus. So now next symbol is plus, right? Now check out, the top of the stack is asterisk and this you can say multiplication, this is having higher precedence and the incoming operator is having lower precedence than the operator which is at the top of the stack. Then you cannot push it here. First of all, pop out this top of the stack, right? Then again check this one with the new top of the stack. Now once you pop out this one and you will append this, or you can say you can print it now after this one. So now the prefix would be, the prefix expression would be, now multiplication we have popped out. Now in the stack I have, now this is the incoming operator plus. Now again check, the new top of the stack is this one. Now again check for the precedence. Still this is incoming operator is having lower precedence than the top of the stack. So you cannot push it. Again pop, right? Now we will pop out this one like this, right? Now new top of the stack is this one. Again check, but still the same precedence of this is higher, so you cannot put here the plus. Again pop out this one. Now check out with this one, same, plus is having lower precedence than the top of the stack. Then pop out this one also. Now in the stack I have plus. Now check out the precedence. These are having same precedence. Now check out the associativity. Associativity is what? Left to right. If left to right, then no need to pop out this thing, simply push the incoming operator. Now we have 2 plus in the stack, right? Now after this plus I have n, so stack would be unaffected and here we will append this. After n we have again asterisk. Now this is having, multiplication is having higher precedence than the top of the stack, right? If higher precedence, then you can simply push it and this expression would be same. Now after this one I have m, so this is what operand, no need to push anything in the stack, simply you will append this into this expression. Now we have minus. Now check out this one with the top of the stack. Now here we have multiplication. So now this incoming operator is having lower precedence than the top of the stack. So you cannot push it. What you need to do? First of all, pop out this thing, this operator, right? So here we have now this one. Now in the stack I have plus and plus, but again this is the new top of the stack. Again check out with this one. Now plus and minus is having same precedence. Check out the associativity, that is left to right. If left to right, simply push this operator here, the incoming operator, into the stack. Now after that I have L. So now this is operand, simply append this one here. After this I have plus. Now check out with this one. Here we have minus, both are having same precedence. Check out the associativity, left to right, simply, if left to right, simply push it. Now next is K. So in the stack I have this one and directly you will write down K here. Now you have reached till end of this expression. Now what you will do, check out the stack and pop the stack, pop out the operators from the stack till the stack becomes empty, right? Now first of all pop out this plus. Now I am writing this here, plus, pop out this one, after that minus, then plus, right? Now stack is empty. Now stop. So now see, this is not done yet, right? Now what you need to do, you have to reverse this expression, right? So for reversing, what you will do, scan this from right to left, plus, and write down from here plus, plus, minus, plus. Now this is the final prefix expression for this this infix expression. Now this is the conversion using stack. Now we will discuss conversion without stack, right? And we will compare our answer with this one, whether we are getting the same answer or not. Fine, see. So now this is a given infix expression, no need to convert it into that reverse infix expression, no need to reverse it. Simply scan this one, right, and find out which operator is having higher precedence, highest precedence. So we know the parentheses are having higher precedence, right, out of all the operator present here. So, fine. So first of all solve this one. Convert this into prefix. What should be the prefix here? This operator should be before these operands. So this is now a prefix of this one. So this is now one operand. This complete will act as a operand. Now next, although this is the operator which is having second highest, but this thing we have already solved because this is within these parentheses, this operator, right? So now after this we have this multiplication and divide. These are having higher precedence. So now here both multiplication and divide both are having same precedence. So check out the associativity. Associativity is left to right. Now left to right means we will start scanning from left, and this is the first multiplication. So first of all you need to solve this one, right? So for this one, for this operator, you can say operands are this one and this one. So convert it into prefix first of all. So for this one, prefix is in second scan. In first scan we have done this thing. In second scan this would be mn. Now this is what? Complete operand, one operand, right? Now scan this one from left to right because these are having left to right associativity, right? Now another is this one, fine. So now you need to solve this one. For this operator, operands are what? See, one operand is this one w, another operand is this one, means after solving this one we have got this operand, right? So now one operand is this one operand is this one, right? Now how to convert this? You can say this is something like this. This is one operand, this is another operand, and this is what? Operator. So the prefix of this one is asterisk, then this operand op, then w. This would be the case, right? So now here what you can write? This one. Here you will write asterisk, this is the operand, and here you will write w, right? So this is now the complete operand. So this is now complete operand. Roughly I am doing this thing, I am not writing each for each scan, right? So that would be very lengthy. Now next is, now after this one, this from left to right, this is the operator, that is this divide. We will solve this division, right? For this division the operands are, one is u and one operand is this complete operand, right? Because after solving this we have got. So this is something like, you can say right like this, w, and here we have this operator and here we have u. So this is one operand, this is another operand, this is operator. So for doing the prefix of this one, you will do what? This operator should be before these operands, right? So this is something like this. Here, I hope you are getting this. So this is now a complete operand. So how you can write down this thing here? Here you will write down divide and w and u. So now this is our complete operand, right? This is another operand. Now next is this one from left to right. Next we have found this division operator. For this division the operator, the operands are, one is v and one is this complete, right? So now this, after this divide, after this v, right? This is one operand, this is another. So how you will convert this into prefix? Simply put this operator before these operands, means here you will put before this operand and here we will write v. So now this is what? A complete operand, and here we have asterisk mn. This is another operand, right? Now after this we have this multiplication operator, right? So now for this operator, operands are, one is t, right, and one is this complete operand. So here you can say, here we have asterisk and here we have t. So one is this operand, one is this one. So put this operator before these operands to get a prefix for this expression. So now here you will write asterisk and here you will write t. So now this is a complete operand, right? Now we are done. We have solved all the multiplication and divide operators here. Now next precedence is of plus and minus, but here we have multiple plus and minus. So which one you will solve first? Same, check the associativity. Associativity is left to right. So scan this from left to right, right? While scanning we are getting this plus first. So you will solve this one first, right? So now for this plus, this is the operand, this is the operand, 1 and 2 operands are there. So for prefix you will write here plus before this k and l, kl. This is what? A complete operand. Now this is what another you can say operator we have found, that is minus. So now we will solve this minus. For this minus, now see, for this minus the operands are, one is this complete and one is this one, that is because this I have already converted into prefix, that is this one. So here you can say here we have minus, right? For this minus, this is one operand, this is another operand. So you simply put this minus before these operands. So now this is what complete operand, right? Now here, now we have this plus, so solve this one. For this plus, see, one operand is, we have solved this one operand is this complete, right? This complete for this plus, and second is what? Second is what? This one up to t, because we have solved till t plus we haven't solved, right? So now you can visualize it something like this. This is one operand, here after this we have plus, and this is another operand till t. So how you will convert this? Put this plus before these operands. So here we will write plus, right? And after that these operands. Now we are left with this plus. So here you can say this plus and q. For this plus, one operand is this complete, right? This complete from here to here, and one is q. How you will convert it into prefix? Simply put this plus before both the operands, that is plus you will write here, and here simply you will write q. So this is now the prefix expression for this infix without using stack. And now you can compare this with this one. I guess both are same. So I guess you have analyzed now that for getting this prefix from this infix expression using this approach without using stack, you need to, or you can say the compiler need to scan this infix expression multiple times. It's not like that in one scan only you can get this prefix, as I guess you have analyzed here. But when you are using stack, in that case compiler need to scan only once this expression from left to right, right? So now it's up to you which approach you are going to follow. So now I guess no need to write down the rules here, because if you get it how to convert this into this, you can write down the steps, because obviously I am going to write down the steps only, and if you know how to convert it, right? So you can easily write down those steps. First of all, reverse this infix expression, right? Then scan it from left to right. If operand is there, simply print it. If operator is there, then what? You will check out the stack. If stack is empty, or in the stack we have closing parenthesis, right? Then simply push that operator into the stack, right? If that is not the case, if stack is not empty, then check out the precedence of the incoming operator. If the precedence of incoming operator is higher than the precedence of the top of the stack, then simply push the incoming operator into the stack, right? But second, another rule is what? If the precedence of incoming operator is less than the operator which is present at the top of the stack, then what we will do? Pop from the stack and print it. Again check the incoming operator with the new top of the stack, right? And if precedence of both operator, the incoming operator and the top of the stack operator is same, then check out the associativity rule, right? If associativity is left to right, simply push the incoming operator into the stack. If associativity is right to left, then first of all pop from the stack and then again check the incoming operator with the new top of the stack, right? Something like this. I guess you can easily write down these rules. No need to write down these rules here. And after that, yes, one more thing is, important point is what? After getting this thing, you need to reverse this expression also. Now this is the final, your you can say that prefix expression. Fine. So now in next video I will discuss with you about binary search trees, right? So I will see you in the next video. Till then, bye bye, take care.